Right, so let's start. All right, what can you tell me about the dimensions and how they relate to the rest of the universe?
Well, pi is universal. If you take try and draw a circle on any planet or anywhere in the universe, your radius will be will have a relationship to the circumference of the circle, 2 pi r, and the square area will equal pi r squared. It happens that in RF engineering, you're constantly relating things back to pi. So you'll always multiply by omega, which is 2 pi f, 2 times pi times the frequency. So when you're designing devices like this, that will have had to be known. And we see evidence that the ancient civilizations knew it. And the best device that records all that information is the Great Pyramid. It's why it's the one that's the most studied. For example, the wavelength that operates inside the King's Chamber of the Great Pyramid would be 2.618 or 5 qubits. A qubit, to give an idea, if you take a radius of 1 meter, if you create a unit circle with a radius of 1 meter, the circumference will be 2 pi. If you divide that circumference by 12, you'll get a qubit. And so the qubit is related to the meter through pi. Is your unit of 1 and your 2 pi divided by 12, and your qubit measurement will then be related to that unit, and that unit, what we call the unit, is the meter. So the qubit is related to the meter. Now inside the sarcophagus, that's 2.5 qubits. Okay, then you get the wavelength, which of the sarcophagus, which is 5 qubits. The width of the King's Chamber is 10 qubits. The diagonal on the end wall is 15 qubits. The length of the King's Chamber is 20 qubits, and the top diagonal opposite to the bottom opposite diagonal is 25 qubits. It's what's known as a cuboid shape. And yeah, there's so much of Pythagoras in there. There's more Pythagoras than Pythagoras itself. So Pythagoras didn't invent Pythagoras. He just rediscovered it. It was recorded in rock thousands of years before him. And in actual fact, on any planet, you would eventually come to the conclusion that you're going to need pi, and you're going to need 1 unit. You can call it what you want. You can call it kangaroos, or you can call it like we did. We called it the meter. So yeah, and the dimensions of this, not this one, but the Great Pyramid, are very interesting. The 440 qubits on the base length, multiply that by 800, and what's it? 440 times 4. So you know that creates a specific perimeter which circumscribes a similar circumference circle around the base, which is quite relevant in terms of the geometry of and relationships between the pyramid itself and the whole of the earth, which then starts to make you think they actually understood the size of the earth and the diameter of the earth and the distance to the sun and the moon's the diameter and all of that sort of stuff, which was possible to work out all those years ago, 5,000, 10,000 years ago. But yeah, so the height of the pyramid, which is 280 cubits, the length 440 cubits, the King's Chamber, the sarcophagus is literally 2.5 cubits. And these numbers are replicated through other history books, like the Ark of the Covenant was 2.5 cubits long, the same length as the inside of the sarcophagus, 2.5 cubits. Remembering that the tuning stone fits into the sarcophagus. That tuning stone was found outside the sarcophagus, and you can measure it. It fits perfectly inside, allowing a 1309 millimeters or 2.5 cubit length inside. So the Ark of the Covenant was 2.5 cubits. The sarcophagus inside the Great Pyramid was 2.5 cubits. The Ark was also 1.5 cubits by 1.5 cubits. So with the frequency, the formula for the frequency profile of a rectangular resonant cavity like the sarcophagus in the King's Chamber of the Great Pyramid and the Ark of the Covenant, it basically, those dimensions of both devices allow for a wavelength of 1 meter. A little bit oversized on the Ark of the Covenant, but then again it's not made of solid granite, which doesn't move. It's made of wood, which when it contracts overnight actually cools, and the coefficient of thermal expansion allows it to cool to a certain degree, which brings it into a 1 meter wavelength replica of the sarcophagus. So if you're talking about resonant cavities for receiving off-earth signals, it seems that the Egyptians were probably the first at receiving at the 1 meter wavelength, not the Israelites 3,300 years ago, but the Egyptians 4,680 years ago. But yeah, those types of devices, they all center around the cubit, and because it can be measured quite easily. It's usually from the elbow to the tip of the fingers, and then there's all sorts of other measurements. But you'll say, well, some people's elbow to tip of the fingers is different to the others, so it can't be a really good measurement. But when you come to resonant cavities, it's to do with the ratio of the number of antinodes, or the ratio of the height to the base in terms of a pyramid. So the unit is unimportant. You can use meters or cubits. It's a ratio of the length to another length. So that's by the by. But yeah, so there would have need to be a meter measurement ruler, definitely. But for the most part, all the workers would have used their own arm, because they're just working according to a ratio. The slant height and everything like that is all determined by ratios of height to distance traveled. And so another interesting fact is that the Great Pyramid's base angle, it sits at 51.83 degrees. And that's quite a critical angle. It kind of allows a uniform illumination of the base aperture. So instead of groupings of signals forming, it illuminates the whole base. So signals are bouncing around, the signal is bouncing around in there, and it's trying to get out and wants to bounce off the bottom and go out. And if you use an angle that's a little bit more, or a little bit less than 51.83 degrees, it's not well, 51.83 degrees allows self-replicating, self-repeating patterns, and disperses the signal across the whole base in a uniform way. So, I mean, that was quite critical to the design of this thing as well. I mean, there's so many facts about the measurements of the pyramids, which blow my mind. And as a resonance engineer, if my mind is blown away, yeah, I mean, when you start to study it, it actually makes a lot of sense. But it's quite interesting that thousands of years ago, they may not have had TV, cell phones, and all the rest.